All right, for this lesson, it focuses entirely on how to use your graphing calculators in order to either solve the area or probability or to find an x or a z-score value using your calculator. It's going to be a little bit more accurate than if you're using the z-score sheets. Now, remember, any of this you can do using the z-score sheets. If you don't have a graphing calculator, don't worry about it. And if you are on the Casios, make sure that you grab that Casio quick reference sheet for stats because it's slightly different, not drastically, but slightly different doing it on the Casio calculator. So that is up in our content section on D2L. So the first thing is when you are going to solve for the area, what you're doing is you're going to be using the normal CDF command, and that will show you either the area between two z-scores, the area to the left of a z-score, or the area to the right of a z-score. When you're putting in the normal CDF commands, the biggest thing is, in this case, it's just putting in, well, okay, I want between these 2 points. And so you're going to solve for the normal CDF between those two z-score points. It always says left boundary on the left, right boundary on the right. And then it will state, well, this is the percentage or probability that it is going to be in between those 2 points. Now, if you are only calculating to the right, then you would state what the lower boundary is. And then for the upper boundary on the right-hand side, if you want going on to infinity, there is no infinity button. So you're just going to put 10 to the power of 99, or the biggest number that your calculator can process. And then it will go to approximately what that is, because you can never actually hit infinity. If you just want to figure out if it's filling to the left, then you're going to put the value for that z-score on the right-hand side, and you're going to put on the left-hand side negative 10 to the power of 99. Now, because your calculator is going to be more precise, the answers obtained may not exactly be the same as those obtained from the table, because it's going to get a little bit more accurate, it can get a little bit more precise and go to further decimal places than what that table is going to do. If you're calculating between two sets of data, you can do this using, instead of z-scores, the data values as well. When you're doing the data values, then all you're going to do is you're going to state the first thing is going to be your lower boundary, the second thing is going to be your upper boundary. The third thing, when you're listing it out, is going to be your mean, and the fourth thing is going to be your standard deviation. And it's still going to calculate the percentage for you. So you can see a picture of what this would look like. Lower boundary is going to be 17, upper boundary is going to be 10 to the power of 99, the mu is 12, and the sigma is 3, and it calculates it. Once again, if you're just doing the area to the left, just like if you're doing it with z-scores, still do the negative 10 to the power of 99. If you're just doing to the right, do the 10 to the power of 99. So, if we're going to try this, then what we're going to put into our calculators in order to solve this is postal outlets have determined that using standard mail service, it takes 3 weeks on average for a package from China to arrive in Canada. They also determined the standard deviation to be 5 days, where it's normally distributed. Now, be careful, because here it says weeks, here it says days. I'm going to change this from 3 weeks to 21 days. And I'm going to state that when I'm drawing my picture, this is going to be 21. I'm going to be solving for when it is to the left here of 15 days. When I'm stating it for my work, all I need to state is what did I put into my calculator in order to solve it. So in this case, if I am solving to the left of this point, then I'm going to state in my calculator my normal CDF is going to be bracket. What did I actually put in? Well, the lowest point was negative 10 to the power of 99 because it's going to keep filling to the left. The highest point was 15. The mu value is 21, and the sigma value is going to be 5. When I put that in, I get 0.12 to the nearest hundredth. For the second case, postal outlets guarantee that a package will arrive in less than 35 days or the delivery is free. Last month, 8,257 packages were sent from China to Canada. How many of these packages would be expected to be free of delivery charge? So, in this case, I still have 21 is going to be my mu. I have my x value is going to be 35. And I'm solving for if it takes longer than 35 days. So the first thing I'm going to solve is what my area is going to be, or my percentage is going to be. I'm going to say that my normal CDF is going to be, the lowest point is going to be 35, the highest point is going to be 10 to the power of 99, and my mu and my sigma are still the same. When I do that, I'm going to get 0.002555, or about 0.3%. If it says how many packages are going to be delivered free of charge, then I'm going to say that it's going to be the total number of packages multiplied by that percentage, or area, 0.002555, which means that it's going to round to the nearest whole package, 21 free packages. For example 2, it says calculate the percentage of the population to the nearest tenth whose height is more than 1 standard deviation above the height of the population. So I'm going to draw my bell curve. I'm going to state that I have my mu is going to be here. If you're better at drawing a bell than me, good for you. I'm going to say that the middle, or mu, would be 0 standard deviations, and it wants for more than 1 standard deviation above. Well, in this case, if I'm doing my standard deviations, then I'm just doing it based on the Z-score. I'm going to say my normal CDF is going to be the lowest point of 1 going up to 10 to the power of 99. And if this is just based on Z-scores, well, my mu is going to be 0, and my sigma is always 1 for Z-scores. This is going to give me 0.1587, or 15 point to the nearest tenth of a percent, 9% of the population is going to fit into that range. If I'm working in the other direction, so I'm not solving the area, I'm solving a set of values, or I'm solving for a Z-score, then what I'm going to do is do the inverse norm. So it's always going to be working in the opposite direction. So if I'm doing the inverse norm of whatever it happens to be, then I'm going to be putting in the data sets. So the order in this case is I put in the area, I put in the mean, and I put in the standard deviation. And then it will tell me where that data set actually exists. So if they did it from the Toasty Toasters one, where it says that the average life for mu was 4.2 years, the standard deviation was 0.65, and the company doesn't want to replace more than 8%, then I'm going to say, well, my area was 0.08, my mu was 4.2, and my sigma was 0.65. And when I put that into the calculator, it shoots out the answer of 3.286, da, 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 da. And in this case, because it doesn't want to offer more than that, I would always, for a word problem like this, round down. No matter what the answer was, if it said that it was 3.9, I'd still round down because they don't want to offer more than 8%. If I went up to 4, it would be more than 8% of the data. So in this case, I'm always going to round down. If I want to solve for a z-score, I do the same thing. I'm just going to say that the area is whatever the area is, and then the mean is 0, and the standard deviation is 1 if I'm solving for a z-score. So in this case, it says, determine the z-score to the nearest hundredth if 1% of the data lies above that z-score. Well, draw the little picture. This would be at 0. The area above is 1%, so 0.01. And I want to solve for what the z-score is. So I'm going to say that I'm going to do inverse normal of 0.99, which is going to be the rest of the area to the left. Because remember, this always solves to the left. 0.99 is the area to the left with a mu of 0 and a sigma of 1. And I get a z-score of 2.33 to the nearest hundredth.